Now let's take a look at a real example. First, let's go onto our GitHub page, github.com/md-support-unit-qc. Then click on Questionnaire Validation. Here is a README file and a demo CSV file. Now click Clone or Download. We will use it for a demo. We save it on our desktop. We could open it up to have a quick look first. Top rows contain question names. Start from the second row. The data contains 20 subjects in total, all numerically coded. This is a questionnaire measure patient satisfaction about the patient's visit to a clinic. 1. Do you feel the conducting health worker explained to you sufficiently the risk of the procedure? 2. Did you feel comfortable during the procedure? 3. Would you recommend this procedure to other patients with the same medical condition? Ratings are from 1 to 10. Now back to the GitHub page. In the README file, there's a link for our current version of the web app. We are ready to go. Let's open the website. This is our web app questionnaire validation using Bayesian confirmatory factor analysis. The left block contains an introduction about the web app, the data file, different steps from 1 to 8, and information about our sponsors. Right panel will show prior plots, factor loadings plot, and tables. Now let's follow the steps. Step 1. Click and upload the file on the desktop. We see now the upload is complete. Step 2. Select variables to include in the factor analysis. We choose question 2.1, question 2.2, and question 2.3. Step 3. Select a number to represent how many different priors will be used, i.e. relative importance of each question with respect to the domain or latent factor, also known as item-to-domain correlation. For example, you may choose 3 if you wish to specify a weak, 1, moderate, 2, and strong prior, 3. This setup allows us to use the same prior for different questions, i.e. different questions may be attributed equally to the prior relevance on how they correlate with their respective domain. Let's say we want 3 different priors. Step 4. First prior is high, second is high, and third is medium. Please refer to the graph on the top right panel for graphical representation of low, medium, and high. These priors represent our beliefs about the relative importance of each question. Step 5. Fine-tuning for each prior item-to-domain correlation factor loading. Let's set the first prior at 0.9. Step 6. Select the prior for each variable. We set the prior for question 1 and 2 high and very relevant, and prior for question 3 to be medium. Now step 7. Analyze with confirmatory factor analysis. We click Run CFA. We can see that the posterior plots for factor loadings and the respective table. Frequentist estimates are off and sometimes go beyond a plausible value of 1. Confidence intervals compared to credible intervals are usually wider and suffer from the same issue of suggesting implausible values due to the small sample size. On the other hand, Bayesian estimates are all within 0 to 1 and are proper to use. Bayesian estimates are 0.8, 0.8, and 0.7 for the 3 questions. We uploaded our belief that question 1, clarity of the doctor or researcher's explanation during participation of the patients, is indeed a good measurement. Question 2 about understanding the goal of the treatment is also a good question with a relative importance of 0.8, and question 3 about sufficient training in treatment procedure is a good question to measure patient satisfaction as well. Bayesian methods offer opportunities to properly estimate relative statistics such as factor loadings, even in small sample size setting, where conventional estimation approaches fail. Step 8. Compile a report in Word document. Click Download. Now the report is right here. Open it up, we will see the current date, report description, summary tables for the factor loadings, confidence intervals for frequentist analyses, and credible interval for Bayesian analyses and related summaries. After using the app, please fill out the SurveyMonkey on our GitHub to evaluate the use of this questionnaire validation tool. Please feel free to contact us at pubmedresearch.stats@protonmail.com. Thank you for watching.